Okay, good morning. So it's 8 o'clock in the morning. So good morning, everyone. Thank you for joining us again on our regular PAASE webinars. So this morning, we'll hear about development of an expert system for diagnosing information system communication networks using rough set theory. Our speaker is currently a full professor at De La Salle University, Manila. He is a researcher in the field of communications network engineering. His areas of expertise are communications network engineering, expert systems, control systems, network design, and optimization. Specifically, he deals with the optimization of communication systems to make them more efficient in functionality. This is for systems to adapt effectively to the industry. He creates simulation models to replicate different scenarios in network design. The results of these research are published in different Scopus journals, and he has a very diversified research interest, and he has recently developed into the fields of biomedical engineering optimization techniques. He has published his work in Scopus journals about cardiovascular disease diagnostics and optimization. All these are fruits of his hard work, long experience, and unrelenting dedication to humbly contribute to the area of communications network engineering. So let's all welcome Professor Aaron Africa.
Good morning, everyone. I am Dr. Aaron Don M. Africa. I am here to discuss a very interesting topic, which is entitled Development of an Expert System for Diagnosing Information System Communication Network using the rough set theory. Okay, I have now shared my slide. Okay, go, let me discuss them. Okay. First of all, as we know, in information system communication network, okay, there are delays in troubleshooting. Okay, basically, these delays happens when there are incomplete information. Okay, for example, you have an unknown variable. Okay, usually diagnostics is a straightforward process. Okay, if the information is complete enough, you can already reduce the possible cause. Possible cause meaning the root of the problem. But there are cases when the information is insufficient to deduce the possible cause. Now, in certain cases, it is possible for us to design an expert system algorithm which can create diagnostic rules, even if the information that we have inputted is incomplete. These rules are in the form of an if-then rules. Okay, what we will use here is the rough set theory. Okay, the a design of this expert system algorithm was done by us developing several data structures. Thus, this expert system can output the correct possible cause even if the information that we have inputted is incomplete. Now, just a short background of the study. An expert system is an artificial intelligence system. Okay? What is that? Is it performs tasks otherwise performed by a human expert. For example, in here, our expert system is for network systems. Okay? The task that the system does is perform is replicates a human expert. Okay, for example, an IT engineer. The expert system replicates the IT engineer. Okay, this type of system usually has a knowledge base which contains accumulated experience and a set of rules. The good thing about an expert system is, for example, you have an IT. The IT is only one person. Okay, he knows the company, for example, he knows the company. But the problem is, for example, that IT, that engineer resigns for whatever reason, the knowledge in the company in troubleshooting the system remains with him. So it also leaves the company. The good thing about the expert system is his knowledge, okay, is placed in an expert system database. So what happens is it just uh, even if the person leaves, the engineer leaves, okay, his knowledge is still retained in the company or in the organization. Now, a common cause of delay in troubleshooting communication networks in network system is trial and error. The problem can be solved faster if the person diagnosing it already knows the cause of the problem, rather than resulting in trial and error. Now, of course, some problems can be solved quickly. There are situations when the problem uh, takes too long to solve, okay, because the person diagnosing it may not know the cause of the problem. Sometimes in network engineering, the problem takes months, days, months to solve, solving much inconvenience, okay, because we do not know the cause of the problem. But the truth is, the cause of the problem is already very simple, okay, we just don't know its cause, okay. An example is in information system communication networks. Okay? For this research, it refers to the internal technical backbone of an organization, solving problem that relates to information system communication networks in their networking hardware, firmware, and software applications. Okay. For example, here in computer networks, you just have a very simple problem. Okay. For example, the a very simplified example is the computer is always hanging, okay. For example, the computer is having a blue screen always. Now since you do not know the cause of the problem, you might do trial and error. You might reinstall the drivers, etc. You might replace the video card, okay. But since you all those trial and error takes too long, okay, because formatting the video card, the the drivers takes too long. But for example, in the blue screen problem, you only have to, for example, just install an antivirus software, then the problem is already fixed. Knowing the problem beforehand saves so much time. Okay, now another example is, for example, we have encountered, this one is common in Windows servers, okay? MOM alerts on server, okay? This is the error code, and this is the first time that we have encountered this problem. Of course, as a network technician, we will attempt several troubleshooting techniques in finding the possible cause of the problem. Now, it is often rigorous, time-consuming, requiring the use of resources. Now, he may guess that the technician may guess that it's a computer virus problem, and of course, reinstall a new antiviral program, or a hardware problem. He may replace the database server, which is, if you replace the database server, it will cost a lot of money. Okay? However, in the real cause of the problem is only MOM alerts on server, which means the server is already full. The solution here is very simple. You just have to shrink the database, which only takes less than 5 minutes. Okay, so if you do not know the cause of the problem, you will resort to trial and error. You may even buy a new database, etc. But the real cause only takes about 5 minutes to solve. Knowing this problem beforehand will save time and resources. This is the primary use of an expert system. It gives recommendation of the cause of the problem. Now, let me discuss the statement of the problem. One of the challenges faced by the information and communication technology (ICT) organization is to sell and maintain products and services with quality customer care to ensure loyalty and continued business. Okay, this ICT, for example, uh, are PLDT, Converge, etc., the Information Communication Technology Company, Sky Cable, etc. Now, of course, for a company to maintain its loyalty to the customers' loyalty, they have to solve the problem as soon as possible. Okay. For example, one server is down. Okay. That company must solve that problem as soon as possible. Especially today that internet is very important. Okay. Just imagine if you just have a today we have online schooling, etc. You just have a 1 hour without internet. So that is a problem. You may miss 1 hour of class, etc. So an ICT company must solve that problem as soon as possible. Okay? One way to achieve this is for the organization to ensure that it has a stable technical backbone, including prompt technical support for its clients. Now, the concerns are reported by its clients must be resolved at the soonest possible time. Now, one solution is for the organization to develop an expert system. Okay? The expert system can be used to find the possible cause, thereby it can solve the problem as soon as possible. This is done for repeatedly occurring problems. Take note that in an organization, usually the problem is repeating. It is just recurring. Okay? Uh, the problem is the technician handling them are different. For example, problem one, okay, already happened about 1 year ago. The problem is the one solving problem one, the technician solving problem one already resigned. Okay? So the his replacement technician do not know how to solve it. So again, he will do a process of trial and error, which takes so much time. Now, in order for the expert system to find the possible cause, the information has to be inputted. However, of course, not information will be available. The main problem is how to develop an expert system algorithm that creates diagnostic rules that can identify the possible cause even with incomplete information. Now, what do I mean that not information is not available? Okay, in order to solve expertise to know the problem, you have symptoms, right? Possible cause and symptoms. Okay. In ICT networks, to know the symptoms, you first have to test the possible cause. For example, in a computer, what are the symptoms? There are blue screen, there are no sounds, etc. Those are oversimplified examples. Okay? For example, you cannot test one of the symptoms. For example, you cannot test if there is a certain error message. There are many reasons for this. One reason is you do not have time to test them, okay, or you do not have the resources. Now, let me give the significance of the study. Okay. Now, one of the new knowledge contribution of this research is the development of a new expert system algorithm. Okay? In here, a new method of making data structures is presented. So we can convert them into the rules of an expert system. Those rules are usually in an if then else format. Now, this algorithm is capable of handling large amount of data, which is good because in an ICT environment, there are many problems, possible cause, there are large amount of data. Okay? Now, uh, this expert system is designed that as you place more data on it because there are incomplete information, it can uh, it can give a more accurate information the more data it has. Now, the size depends on the capacity of the database. Now, this research will provide a method to know which are the minimum symptoms needed to identify the possible cause. Now, this is done, we did this by making sure the rules of the expert system algorithm are nominal. Nominal, it means that the rules are reduced to the minimum number of symptoms required to be known in order to identify which is the possible cause using the expert system algorithm. Now, In here we apply the mathematical model. The application of this model produced in this research will make it possible to make a conclusion even if the information available is incomplete. Okay, let me give a simple example. We have four cases. Okay, these are the examples of symptoms and possible causes. Case 1, case 2, case 3, and case 4. Okay, in here, table 1 shows an example list of information system communication network. The first column, okay, contains the case number. Okay? The second column contains the possible causes. The third column contains the value of the uh, symptoms and possible causes. For example, in case 1, the possible cause is we have an FTP software trouble. This is most common in information system communication network. As a background, FTP is what we use when we are downloading large files, especially large files. Now, its symptoms are FTP connection error appears, network drive network cannot be accessed, destination unreachable, page cannot be accessed, error appears. Now, for case 1, in order for us to know that the possible cause is FTP software trouble, we have to check if these four symptoms appear. Same in case 2. Okay? Possible cause is server connection failure. Here are these causes usually. Network drives, destination unreachable, page can be accessed, etc. Now, in this one, okay, what we do is we write it in an information system. Okay? E is the number, it's just a sequence 1 to 4 in this oversimplified example. Now, D is the possible cause, Q is the symptoms. Okay. In case 1, for example, PC1, S1, S2, S3, and S4, okay, has to be 1, meaning 1 is it exists, 0 if it does not exist. Okay, 1 if it's there, 0 if not. In PC1, S1, S2, and S3, and S4 has to be present, okay, in order for it to be the problem. In PC2, server connection failure, only S2 and S2, S3, and S4 has to be there. Okay? Same in case 3, another server connection failure. Can be exist when S2 and S4 exist. PC3, okay, email queuing increasing problem, S2, S3, and S4 has to be there. Now, let me discuss the conceptual framework of this research. The conceptual framework shows the overview of the following. First is how the expert system creates diagnostic rules from raw technical data in the database. This is shown in data structure 1. Okay? This is the knowledge. Later, I will show the PowerPoint of the figure of the data structure. Number 2, which database new technical data is entered and how repository was used in the research. In the fourth, how the database is created. The fifth, how the symptoms inputted in the expert system software are compared to the knowledge base of rules on the expert system. This is done in data structure 5. Okay, in order for the expert system software to output the possible cause. And 6, which programming is used to write the program, the expert system program. We actually created a software for this, okay, because it can be used in the telecommunication company. Now, in the seventh one, which encoder program is used by the software. Okay. 8, which program is used to debug the software code. And 9, which database program is used by the expert system software. Okay. Let me just show here the diagram of the conceptual framework. Okay. Bear with me. This is a little bit long. Okay. First, let's If you can see the pointer, okay. First, let me start with data structure 1. Okay. Data structure 1, okay, contains the database of the raw technical data. Okay. The database of data structure 1 is stored in a MySQL database program as shown here. As shown here in MySQL. In here, we use the MySQL as the database program. The raw technical data, okay, contains the symptoms and the possible causes which are experienced by the technician in the field. The raw technical data, okay, is in the form of notes. Usually, they just write it in their notebook, or if they have a spreadsheet notes, they write it there, and that is the raw technical data in data structure 1. It, it contains a journal of the technicians on their troubleshooting experiences. Whenever a new technical data is basically encountered, okay, uh, those are put in data structure 1 using the graphical user interface GUI in the MySQL software. Now, the expert system retrieves the information on the database on data structure 1. This one is the raw technical data, okay? Then it now goes to the expert system itself. The expert system software, we called it the Information System Communication System Software, or the ISCN software. The expert system algorithm, okay, then tags the possible causes and the symptoms of the data in data structure 1. It has a corresponding, it will be given a corresponding ID. The expert system algorithm is called the ISCN expert system algorithm. Now, what will happen is the data will be written in a table where the first column contains the case number and the second column contains the number of possible causes and symptoms. And the third column contains the value of the possible causes and symptoms. The table will be the database of data structure 2. Okay? Now in data structure 2. It is called the database of tag data and contained in the MySQL database. Okay? Basically, that is what we will do. Okay, now, the conversion of data structure 2, then from data structure 2, we will now go to data structure 3. Okay? Data structure 3 is called the database of net dependency structure. It's automatically done. This one is automatically done by the expert system software. This process is done by creating a table which tabulate the rows and table of an information system. The one row corresponds to the case, okay, case number, and the other row corresponds to the symptoms. Okay? The symptoms, okay, as I shown earlier, we have a value of 1 if it exists and 0 if it does not exist. Now, whenever there are duplicate entries in the system, okay, those are automatically removed. Okay, this is done in data structure 2. This table will be those table which the system are removed is now will be in data structure 3. Okay, data structure 3 is called the database of net dependency structure and contains in the MySQL database program. The rows of the data structure tree contain the value of the corresponding symptom needed to identify the possible cause. In here, data structure tree. It contains the value of the corresponding system needed to identify the one. Now, the first column of data structure tree contains the case number. Second column contains the name of the possible cause, and the succeeding column contains the value of the symptoms. Now, the Roxy in here, the Roxy theory, okay, is used on the data of data structure 3 in order to convert it to data structure 4. The ISCN, okay, we use the ISCN expert system software, applied the RAPSE theory on data structure 3 in order to do the automatic conversion. The process is done in order to identify the minimum number of symptoms that are needed to be known in order to identify the problem or the possible cause. Now, each rows of data structure 4 will automatically be converted as a rule in the ISC and expert system algorithm. Okay? This process is done to make the rules to be used in the expert system. The rules that are repeated rules, okay, they are removed. And the possible cause with the same set of combination will be written in what we call the approximate rules by the expert system software. The rules will be in data structure 5. Now, the rows in data structure 5 are called nominal in nominal form. Okay? Meaning only the minimum rows are needed in order to find the possible cause. Data structure 5 contains the rows that are in nominal form where it is reduced only to a minimum number of symptoms. Knowledge base of the rules used by the expert system is in data structure 5. This is the one that we'll use. This is the final form. Okay, data structure 5. Now, the symptoms of the problem are entered in the expert system. These symptoms are compared. There is a comparison. The knowledge base of the expert system in the data structure 5. If at least one symptom has an unknown value, there is incomplete information. Okay. And then this is the all the data structure. This is the one that we use to do the expert system. For example, in data structure 5, S1 is equals to 1, then D is equals to BC1, then we only have to know the value of S1 if it is equals to 1. Now, of course, we created a program in the expert system. What we use in the program is the PHP program. Okay. Now, you might be asking why we use the PHP. PHP is done to make the program web-based. Okay? Because in a telecommunication company, it is better to access it anywhere. Okay, so we made it web-based. Also, this program is compatible with Windows operating system. Also, of course, if it's web-based, it can also be accessed in cell phones, in Android, etc. Okay, to encode the software, what we use, okay, is the Notepad Plus. Now, what's good about Notepad Plus, it automatically highlights the wrong syntax. If you have a typographical error, it highlights it, the PHP code. Now, in order to debug the PHP code, what we use is the Xdebug software. Okay? What's good about the Xdebug software, it has an autocorrect feature, which gives us suggestion on what to do in case there are errors in the PHP code. Now, the debugging process, we debug it every 3 pages of code or whenever a PHP function is, we code a PHP function. This is done in order for us to detect early and make proper changes because if we debug it after a long time, it may be hard now to find the code. Now, we host it in a server with the Windows operating system. Okay, but of course, PHP, it can also be tested using Linux. Okay, the database program that is used, PHP is usually bundled with MySQL. Okay, that's why we use MySQL. Okay, now let me discuss the rough set theory and the decision matrix. Okay, the decision matrix, of course, is part of the rough set theory. Okay, decision matrix is used in order to identify the minimum number of symptoms that are needed to be known in order to identify the possible cause of the system. The decision matrix of the Rap-Set theory is used. We use it in what we discussed earlier in order to convert data structure 3 to data structure 4 in the expert system algorithm. Now, to create the decision matrix, okay, we choose the first, we choose the target possible cause from the information system. Then we create a table where the rows will contain the cases where the target possible cause is present and the columns will contain the cases where it is not present. Now, the intersection of the decision matrix, we write the symptoms of the target possible cause and where the symptoms are equal to. Now, the items are all in each shell of the table are disjunctively combined and the sets in the column are conjunctively combined. This is done in order to create a Boolean expression where all the system needed to identify the possible cause are in the expression. Now, of course, we simplify them using Boolean algebra. Okay? Now, let me show the concept of an incomplete information. Okay. In an incomplete information, this concept exists if there is at least one symptom that is unknown. Okay? The unknown value is represented in the symbol asterisk. Okay? Example in table 3. Okay? We show table 3. Okay? Hmm. In table 3, usually, okay, information system with an unknown symptoms. Okay? E equals 1, this is the number, this is the possible cause, Q is the symptoms. Okay? In here, the possible cause S1, we know if the value of S1 is 1. Okay? The value of S3 is 1. The value of S4 is 1. The problem is S2. Okay? We do not know the value of S2. Okay? We don't know if PC1 will be 1 if the value of S2 is 1 or 0. Okay? That is the good about our expert system. We can know the value because it will be converted into nominal rules if we know the value of S2, even if we do not know the value of S2. Now, the if then rules are converted in the information system. For example, I said earlier, S1 is 1, S2 is 1, S3 is 1, S4 is 1. Now, the symptom S1, S2, S3 will have a value of 1 if the symptom exists and 0 if the value exists. Now, if we can convert it into nominal form, okay, using the Rapset theory, S1, the rule S1 is equals to 1, S1 exists, D is already PC1, okay? So, going back to the problem earlier, okay, this is the original rule, we have to know the value of S2, okay? But if we use Rapset theory and we know the value of S1, we only have to know, we only have to discover what is the value of S1, okay? We already know that the problem is PC1, so it will save us much time. We do not have to find the value of S3, S4. We only need to find the value of S1. Okay? Of course, S2 we cannot find its value because it is unknown. Okay. Now, theoretical considerations. Okay. The expert system was just a short background. Is one of the first applications to emerge from the primary research in AI, artificial intelligence. Okay? The explanation of vector system reasoning was one of the applications to emerge in natural language generation. The expert system, it works like an interactive system. Okay? It responds to question and asks clarification. It also makes recommendations to guide the user in the decision process. Okay? Basically, an expert system has a GUI. Okay, you just enter it, then there are answers. Okay, it gives suggestions. Expert systems are domain specific. Okay? It is very hard to create an expert system uh, that caters all of the disciplines. Okay? In here, in our research, our focus is only information system communication networks. Okay, IT. Yeah, we are focused on that discipline. Now, the programmer of an expert system must limit the scope of the system to just what is needed to solve the target problem. Of course, there are specialized tools that we use to accomplish the objectives of the system. Now, complex knowledge combinations. There are factual and heuristic knowledge. The knowledge, of course, it must be organized to make it easily accessible in an easily accessible format among the data, knowledge and control structures. Actually, this is what we done converting the one I discussed earlier, data structure 1 to data structure 2. Data structure 1 is in the form of nodes. In data structure 2, we made it into a distinguishable format so it can be applied, so it can be converted using Rafset theory in mathematical. We can already use mathematical systems on it. Now, this is just an example. In figure 2, expert system organization environment. The reason why expert systems are organized in three distinct levels are first, the knowledge base. Okay? Let me just write it. Okay. Here, the knowledge base. Okay? It consists of problem solving rules, procedures, and intrinsic data relevant to the problem domain. Of course, we have the working memory. Okay? It refers to the tasks of the problem under consideration. Okay? This one is usually our database. Okay? Then we have the inference engine. Okay? It's a generic control mechanism that applies the approximate knowledge. Okay? In the inference engine, okay, what it done is task specific data to arrive in the same conclusion. Basically, this is where our algorithm is. Okay. Now, categories of expert system. There are several expert system categories because of its widespread use. Below are some of it. First is diagnostic. It refers to the system malfunction from observations. Okay, type of system include medical, electronic, financial analysis, auditing. Actually, medical alert system, they are used for diagnosis. Monitoring, okay, it compares observation in order to plan the vulnerabilities. Okay, this type of system includes management control, for example, in nuclear power plant generation. Okay, debugging, okay, this one is used to prescribe remedies for malfunctions. Okay, this type of exception includes computer software repair, etc. Of course, kung repair, post focus on repair, it executes a plan to administer a prescribed remedy. Type of using the automobile, computer, and telecom. Basically, our system is focused on the repair side. Instructions, okay? It diagnoses the bugs and corrects the student behavior. Type of system includes tutorial and remedial. Control, okay, it interprets, predicts, and monitors system behaviors. This type of system includes traffic control, battle management, etc., and prediction and handles the possible consequences of given situations. This type of system includes weather forecasting, crop estimation, and financial forecasting. You have interpretation, it refers to situation different for sensor data, etc. Design, okay, configure subject with situation constraint. This type of system, for example, in designing IC PCB, circuit layout. Okay. Planning, okay, develops guidelines for action. Type of system includes strategic planning, process scheduling, and military planning. Okay. Now, the following are, as I discussed earlier, the knowledge base, inference engine, user interface, etc. Of course, what's important is also the knowledge acquisition. Okay? It involves a collection of data from experts on desired domain. This is the one that what we have in information system communication network. These are the notes of the technicians. Okay? They write it in their notebook, then we convert it. They are data structure 1 and it's converted to data structure 2. Now, it is a dynamic process, okay? Because it involves using various techniques and employing different activities, which aims to getting reliable data. Now, this is what it's good about an expert system in an organization because whenever there are new problems, okay, you just input it in the expert system, okay? In theory, the more data the expert system has, the more it can give a more accurate information, okay? So, If every technician in a large company just place their information in the expert system, so example, there's a new hire, it will just use the expert system. They will just write the symptoms and the expert system will already give the possible cause. Okay, the fifth one is in here is knowledge representation. Okay, it is the formatting used to structure the knowledge into forms in the form of semantic network and decision table. In short, knowledge representation is a tool to describe the way people think and use things they know. Okay. Now, of course, there are paradigms. The paradigms tell us how people use or process the knowledge they possess. But of course, not the details of the knowledge domain. Uh, this one becomes detailed through knowledge representation when we already place it on the table. Now, its purpose of having this type of structure is to enable the system to exhibit intelligent behavior as a certain kind of AI type of behavior. Okay, let me now show you the a chart of the processes performed by the ISCN, the algorithm expert system algorithm. First is the I have to make it a full screen for you to ship. First one is data structure one. Data structure one, okay, contains the database of the raw technical data. Okay? This database contains the log of the technicians of the possible causes and the symptoms that they experience in the field. ISCN expert system algorithm tags the possible causes and symptoms of data structure 1. It will be given a corresponding ID. And then the places of the place it in the information table, where the first column contains the case number and the second column contains the possible cause. Now, the table created will be the structure for the data structure 2. This is called the database of tag data. Expert system algorithm places each data structure in the rows of the table of an information system. In here, one row corresponds to one case. The expert system will have a value of 1 if it exists, 0 if it's 0 if it does not exist. The expert system algorithm removes rows with identical entries. Okay, example, it doubles. The table created is called data structure 3. It is the net dependency of data. The rows of data structure tree contains the value corresponding symptoms needed to identify the possible causes. The first column of data structure tree contains the case number. The second column contains the name of the possible cause, and the succeeding column contains the value of the symptoms. Now, the decision of the rough sector is applied from 3 to 4. Okay? The decision matrix was used in order to identify the minimum number of symptoms needed in order to know to identify the possible cause. The rows of data structure 4 contains the name of the possible cause and the value of the corresponding symptom of the possible causes. The first column of data structure 4, okay, will contains the case number. The second contains the possible cause, and the succeeding column contains the value. As I said earlier, the symptom will either have a value of 1 if it exists, 0 if it doesn't exist, and an asterisk if we don't know the value of it is unknown. Data structure for contains only a minimum number of symptoms required in order to identify the value per cause. Okay? This is called information dependency or trim data. The expert system algorithm writes each rows of the table in data structure 4 in the form of rule. Then it becomes data structure 5. The one that the expert system used, the PHP program, is data structure 5. Okay, now let me discuss the ISC and expert system software development. Okay, the first one, in the first chart, we program the expert system software using hypertext processor, or we use PHP programming. This was used because it can make the expert system uh, web-based. Okay? And it can run in different operating system like Windows, because PHP supports Windows and Linux. Okay, the software that was used to code the expert system is Notepad+, as we said earlier. Okay, then we use Xdebug. Every 3 lines of code, we debug it. Then we host the expert system software in a server using Windows operating system. Then we use MySQL as the database of the system. Okay. Then of course, as the host server, what we use is the WAMP server. Now, let me discuss how we validated the output of the data. We use two methods. Okay. The first one is validation through empirical testing. Validation through empirical testing is shown in figure 5. First thing we did is to count the number of rules produced by the helper system algorithm. The result will be defined as variable A. Then we check each rule that is produced by the expert system algorithm in the information system to see if the rules of the symptoms match. Then we count the number of rules where the values of the symptoms match in the information system. This one is defined as variable B. Then we compute the percent validity of the rules of the expert system. Let C be the percent validity. The equation is C is equals to B divided by A multiplied by 100. Then the next test that we did is we test with historical data. Basically, the company already has logs. It is the possible cause. These are the symptoms. We use those data to verify it. We count the total number of historical data, and the result will be defined as variable D. We input the symptoms of the historical data to the expert system, then we check if the possible cause outputted by the expert system equals to the possible cause of the historical data. Then we count the number of possible cause outputted by the expert system. It is the result is defined as variable E. Then we compute the percent score. We give it a variable F. That F is equals to E divided by D times 100. Okay. In here, this is what the one that I just shown earlier. Okay, this chart contains the information system dependency structure. First, you have data yan, data structure 1. Okay, these are the cannot be read. I plan to write in here. Wait. Okay. Data structure 1. Okay, this is the raw data. Okay, the raw data is the one that in the form of notes of the technicians. Then those possible cause in the form of rough notes will be given an ID. It will be in data structure 2. Okay? And then each case data structure view will be placed in rows and the symptom in columns. If it takes one row corresponds to one case, it will have a value of 1 if it exists, 0 if it does not exist. Okay? Then data structure 3 is the database or net dependency structure. In this one, we will use the rough set theory in a decision matrix. Okay, we choose the target possible cause from the information system in data structure 3. Then we will create a table. The rows will contain the cases where the target possible cause is present. The columns will uh, contain the cases where it is not present. Okay, the intersection of the decision matrix will be the information system. Also, the items are in each cell of the table are disjunctively combined and the cells in the columns are conjunctively combined. We simplify them using Boolean algebra and we repeat the process in each possible cause. Now each expression will be placed in the rows of an information system and this table will be in data structure 4. This one will be the trim data. Okay, basically, Lapse theory is the conversion of 3 to 4. Now each rows will be written in a rule form, if else rule form. If there are two or more dependent symptoms, they are conjunctively combined. The value that is considered. Okay. Now, in data structure, in 4, we trim them. We remove the redundant rules because when we apply drafted theory, there might be rules, two or more rules that are the same. We just remove them. Then it becomes data structure 5. They are the nominal form. This is the one that is used in the expert system program. It contains the knowledge base of the rules in the expert system algorithm. Now, data and results. We have the presentation of actual data. The algorithm will be tested and validated using the actual data. These data are the problems encountered by a network support division of an information system, communication network telecommunication company. For confidentiality purposes, we will not disclose the actual name of the company. Okay. There are a total of 165 cases. Of course, I can only show you 6 because it will not be uh, placed in the PowerPoint. Okay. Table 4, it contains the symptoms in computer diagnosing with possible cause. Okay. And we just use a pointer. For example, case 1, possible cause is runtime error. The symptoms, motherboard beeps and computer virus message. Now, in modern experience, if the motherboard beeps and there's a computer virus message, the problem is usually a runtime error. Uh, in case 2, if there are divide errors, okay, that's the possible cause. The symptoms are that is visibly seen is computer motherboard beeps, there is a mother memory overflow message, and the error message regarding the auto exec bat or config.sys, and so on. Now, you may be asking, what if we know that the possible cause, for example, PC1 is already, we already know that it is a runtime error. Now, that is usually they have a log. Okay? If the possible cause is PC1, runtime error, this is what you will do. Okay? Some of you just have to install a certain program to remove them, or you have to uninstall a certain program to solve runtime error. Actually, if you already know the possible cause, okay, the solution is already there. It's already easy. The hard one is knowing what the possible cause is. Because if you do not know the possible cause, some of the real problem is runtime error and you thought it is a MSGS arbitrary-to error or a divide error, you will do the solution that is intended for divide error and MSGS SBR32 error. But the real problem is runtime error. You might make the problem worse, or uh, it's time consuming, okay, because you have to solve it using divide error. Uh, Wait, wait. Now, here is the information system of data. Of course, there are already a lot of data we write it in a information system. E is the number of cases, D possible cause, Q is the symptoms. Okay? For example, PC1, what must exist is S1, S2, and S2, and the rest must not exist, so 0. Okay, we just write it in a information system. Now, in table 6, it shows the table of symptoms. Basically, we have 30 symptoms. These are the sample complete TSR, computer virus message, in symptom 6, USB virus message, etc. Okay, initially, okay, without complete the algorithm, the above data has 165 rules. Okay, one rule for every case. The rules are in table 6, it shows the initial decision rules. Okay, for example, in rule 1, S1 equals to 1, S2 equals to 1. The rest is 0 for the problem to be PC1. Okay, same in 2, 3, and 4. Basically, 165 rules, but I did not write the whole 165 because it will not be in the PowerPoint. Now, note that we applied the algorithm that is shown in section 4, okay, the one with the data structures, okay. We used a program to do it, okay, which is the rough set theory. Basically, from 165 rules, okay, it just becomes uh, 109 rules. You approximately have a reduction of 33.9. Okay? For example, PC1, okay, instead of looking if everyone, those all exist, we just have to see the value of S2. Now, okay. Then, we now do the testing. Testing is done in two parts, empirical testing and historical data. Now, let's do empirical testing. Okay. The validation through empirical testing. The first part of the validation was empirical tests. This process is used to check the validity of the rules. Applying empirical tests of the rules produced by the expert system algorithm. Now, first we count the total number of rules produced by the. Okay, let me just use this so I can write the total number of rules produced by the expert system algorithm. In here, it's 109. Okay? Then we check if the rules produced by the expert system algorithm is with the information system. For example, we check rule number 4. Okay? In rule number 4, S4 is if S4 is equals to 1, S6 is equals to 1, and S7 is equals to 1, then the problem is PC4. Okay, as you can see, PC4, okay, S4 is equals to 1, S6 is equals to 1, and S7 is equals to 1. Therefore, we can do this validation. Okay, we just use it in each of the rules produced. Now, here is the table 8. Basically, there are more. I just write the 11 rule, the 11 one. For example, in rule 4, okay, kita ba? In rule 4, the one that we do, rule is PC S4 equals to 1, 4, 1, S6, 1, S7, 1. Okay. Cases PC4, the value of the cases in the information table is 1, is S4, 1, S6, 1, S7, 1. Okay. So this is already a check. So we can conclude that this is uh, equal to the original information system. Okay. Then although in our check, all the 109 rules match the information systems. Okay? Then we count the number of rules where the value of the symptom match the information system. The total number match is defined as variable B. Okay? It will be variable B. Now, the total number is 109. Okay? Substituting, okay, A is 109, B is 109. So our equation is 109 divided by 109 multiplied by 100. We can conclude that the validity is 100%. Okay? Now, next is we test with historical data. Okay? The expert system that will be inputted will be tested through historical data. This will be used as the validating data. These data are obtained through the retrieval of the information in a live scenario. The possible cause is already known. The test is done is as follows. First, we count the number of the historical data. Okay? The total number of the historical data will be defined as variable D. Okay? This test has a total of 50 historical data. Therefore, D is equals to 50. Then we input the symptom of the historical data to the expert system. Check if the possible cause outputted by the expert system equals the possible cause of the historical data. Now, because with historical data we have 50, but I can only show 15 because of the PowerPoint. As you can see, uh, case 2 is in the, for example, in case 2, okay, if the symptoms are S4, S26, S20, S30, the expected output is PC69. Now, the expected output is PC69. Now, based on the historical data, the system output is also PC69, so they are equal. Okay. Now, in the system, okay, we have two errors. Okay, when we input S1, S2, S6, and S9, the expected output is PC47, but the system outputted PC44. Okay, and also in the ninth case, we inputted S2, S7, S9, and S18. The expected output is 14, but our output became 52. Okay, so example in case 9, which has S8, the URL cannot be accessed through NDB. S9, network connection error appears. S10, map drive cannot be accessed. S15, CPU hangs. Then what we expect is 7, and what we output is also 7. Then we compute the number of possible costs, where the possible outcomes outputted by the version equals to the historical data. It is defined by the variable E. Okay? Basically, uh, we have four that is not equal. So our value of E is equal to 46. Okay? Then we come with the percent score. The formula for the percent score is F is equals to E divided by D times 100. So, substituting D is 50 is 46. 46 divided by 50 times 100. The value of the accuracy historical data is 92%. Okay? Now, let me now discuss the conclusions and recommendations of my research. Okay? This research has developed an expert system algorithm that can handle incomplete information. Now, using the data structures, an expert system algorithm was developed. The algorithm involves a novel technique to input, tag, and properly structure technical data so they can be converted into the rules of an expert system. Now, the created rules from the algorithm are nominal, meaning they are reduced to a minimum symptom required to be known in order to identify the possible cause. The research solved the problem on how to develop an expert system algorithm that creates diagnostic rules that can identify possible cause even if the information is incomplete. Now, we tested in two ways by empirical testing, okay, and testing with historical data. Now, the empirical testing resulted in a 100% validity, while the historical data resulted in a 92% validity. The expert system algorithm is useful. It's useful when diagnosing information system communication network because when we suggest the correct possible cause, even if there are incomplete information, thereby we will save time in troubleshooting. Our recommendations. Okay. It is recommended that this research be tested and used in other areas that need diagnosis. Okay. Uh, as I stated earlier, expert systems are only specific based, are knowledge based, are area based, okay, domain based. Its domain is information system communication networks, com, computer data, okay, IT. But of course, the algorithm can be used in production system as long as it has possible cause and symptoms relationships. This expert system can handle incomplete information system, but incomplete information, but only to a certain degree of incompleteness. Of course, if in one possible cause all is unknown, it cannot handle it. Okay, there's still there is still needed to be certain amount of data. Now, the degree of incompleteness depends on the data in the database of the data structures. Now, despite the limitation, this expert system will still be a great help in diagnosing because the required symptoms that are needed to be known in order to identify the possible cause to a reduced minimum order. Okay? Thank you very much. That is my presentation. Okay?
Okay, thank you very much for that presentation, Aaron. So I encourage all our viewers to type in any comments or questions that you may have. Okay, so maybe I'll just start it off. Yeah, so Aaron, you mentioned that you tested this particular system for both empirical and historical data.
Yes.
I might not have been able to catch it, but what was the difference? I mean, how do you classify empirical and historical data?
Okay, that's a very good question. Okay. For the empirical data, it is the one that we uh, at first we will make a ano at first we will get a data and we will use those original data and convert use theory the ISCN expert system algorithm and convert them into the rules of the expert system
Mm-hmm.
from those data. In, in empirical testing, the test that we the data that we use for testing is from the training data that we use.
Oh,
Okay?
okay.
That that is the empirical testing. We make sure that the value of the nominal rules and the value of the training data are equal, okay, in their symptoms and possible causes. Now, in the historical data, there are data that is not from the training data, the one that we from the rules
Okay,
that
okay.
we entered. Okay? Then we do the check. That is the difference of
I
the
see.
historical data and the
Okay, okay.
empirical testing.
All right. Thank you for that, Aaron. Okay, I have one question from Robert Lico. So, what is the basis or process for choosing this type of theory? So, why rough sets?
Actually, there are many type of uh, algorithm like neural network, etc.
Yeah.
We,
Mm-hmm.
we use rough sets because it is an advanced artificial intelligence uh, algorithm that can reduce the data. It is but still give an accurate representation. It is particularly useful in network information system communication networks because in the information system communication network there is a large amount of data. Okay,
Mm-hmm.
and rough set is specifically designed for that, for large amount of data. That's why we use rough set.
Okay. So, okay. So, any other questions from our viewers? So, but for example, for this particular theory, are there certain limitations or disadvantages to rough sets when you compare it with other types of AI or machine learning algorithms?
Actually, humans. Uh, First, let me give the advan. This system is designed for incomplete information. Okay. Actually,
Okay.
why we use rough sets? Maybe the one of the biggest advantage is compared to other system like neural, etc. Based on our initial test, this one can handle incomplete information very well. Okay, rough sets can handle incomplete information. That's why we use it. Maybe in a disadvantage, okay, it can only handle a certain amount of incomplete information. For example,
Okay.
you have only one possible cause and there are so many incomplete data. Uh, uh, we cannot find the a correct answer if the data is very incomplete. They maybe just
Okay, of course.
very incomplete. That's a very disadvantage of offsets.
Okay, thank you. Raymond says he has a question, but I can't seem to find the question. Raymond, are you there? Yeah, can you please just ask the questions? I don't know where your question
Okay,
is.
good morning.
Sorry, sir.
It was taking too long to type. First of all, thanks for your lecture on rough set theory. First, I have a comment, then I have a question. Uh, I think what you presented is very nice because we may not realize it, but humans generally tend to think in if-then statements
Mhm.
when we're trying to solve problems. And rough set theory obviously allows this process to be reflected algorithmically. And
Yeah.
certainly, in an age where people seem to equate artificial intelligence with neural networks only, especially those who are not specialists, it's interesting to see that there are alternative methodologies.
Mhm.
So my question is, do you have recommendations on research topics for the audience where they can use rough set theory and rule-based models like this?
Uh, actually, rough set theory can be used if the data is in an if-then format. Okay, one good recommendation here, which I think is very relevant today, is biomedical systems. Okay, in
Mhm.
diagnosing medical systems. Okay, as we know in medical system, they are in an if then format. For
Mhm.
example, your eye is itching. Okay, what are the symptoms? Okay, you have red eyes, etc. Then the possible cause is maybe you have sore eyes,
Right.
something like that.
Or
Versing-
COVID-19?
Yes, COVID
Yeah.
19. Actually, that's my recommendation because it's a good topic, especially in our situation right now.
Yeah.
Yes.
Okay.
Tama. Thanks.
Okay, I have a follow-up question from Robert. So he says that the research is applicable for telco troubleshooting. So for future studies, is it possible to include loop back system in order to relearn and minimize manual system updating?
Actually, that is how this system is actually designed. Okay, I it is designed in a telecommunication company. Okay, in a telecommunication company, the technicians, for example, there are lots of them. They are deployed in the field. Usually, they will write the symptoms and possible cause in their notebook. Okay, in the notes. Then maybe the company can make a a process where the technicians will input it in the GUI of the expert system. Okay,
Mm-hmm.
they will write their symptoms, the one that they have encountered, and their its possible cause. And of course, this algorithm is designed the more data that you place on it, the more better it becomes. So actually, every time you place a new data, it will develop a new algorithm, a new rule, new type of rule ano data set. So yes, it relearns every time you place a new data. Okay. Uh, maybe every night when there are no more usage, they can use the server to process the data that they entered in the morning. Okay, that is the learning process. Thank you.
Thank you, Aaron. I think Marnel has a question. Marnel,
Hi, good morning, Aaron.
good
Good
morning.
morning.
Yes. Thank you for sharing this research, Aaron. I attended late, quite late, so I was I missed some parts of your presentation. What will happen again if cases have the exact symptoms, and what will be the output recommendation of your system? So it will. I'm assuming it will output multiple recommendations. Is it correct?
Yes, yes. Actually, that's a very good question. Actually, there are problems in any field that have the same symptoms, but they have different possible causes. This also happens in information system communication networks. Okay. Now, what is uh, what we will do there actually is if, for example, if the computer does not boot and if a certain error message appear, the possible cause, for example, can be a blue screen or if it has a virus. Okay. Now, what we do first of all, the expert system already specifies the specific type of problem. For example, in the initial time you have 10, you suspect 10 possible cause, it will just be down to 2, for example. Now, if the 2 has a uh, same symptoms, okay, what we can do there is we apply a conflict resolution
Mm-hmm.
algorithm. Okay. Actually, uh, we have a research about that when we follow up there, we created a conflict resolution algorithm using logic scoring of reference. Okay, for same symptoms but different possible cause. But that is for a different topic and that is for a different talk. That algorithm that we created.
Okay. Okay. Thank you. I think we've exhausted all of the questions. Aaron, would you be willing to share with us the presentation so that I can also send it out to our participants here?
Sure, I will
Okay.
email it to you.
Okay. Thank you.
Problem.
Okay. So, do you have any final words for our participants?
Okay. Rhapsody is a very interesting topic. Okay, if you are taking your master's or PhD, okay, it can be a good topic to look into. Okay, now if you have any questions, okay, you can email me at aaron.africa at dlsu.edu.ph. Okay, if
Okay.
you have
Thank.
any question about, for example, you are still thinking of a dissertation or a master's topic or you just have a research that you want to do, we can discuss it, okay? Because as I said earlier, Rapset Theory has a wide range of applications. Okay, thank you.
Okay. Thank you, Aaron. But before we end for today, I will just announce the lecture for next week. Okay, so thank you very much, Aaron, for sharing with us your research this morning. So next week we have an invited lecture through Professor Joel Coelho. So our speaker will be Dr. Mario Martuni, who is from the Simon Center for Geometry and Physics and the C.N. Yang Institute for Theoretical Physics. He will talk about understanding geometry through nature and nature through geometry. So that will be next Friday, the same time, 8 o'clock in the morning. So if you're interested, please register at bit.ly/mmartuni. And again, I'd like to invite everyone to visit our webpage at paase.org for any updates on the activities of the organization. And all our webinars, well, most of our webinars will be uploaded in our YouTube PAASE Webinars channel, bit.ly PAASE Webinars. Okay, so I guess that's it. Thank you very much, everyone, for joining us this morning, and hope to see you in our future lectures. Good day.